Okay, 6.6 day 4, we're going to use log property to solve logarithmic equations. So we're going to continue to solve logarithmic equations, but there will be times when we need to condense the logarithms to put them in a single log so we can rewrite it in exponential form. So let's look at the first one. It's log base 5 of 7 plus log base 5 of x plus 1. I cannot put it in exponential form because I don't have a single log. So I'm going to use my log properties. Since these are both log base 5, when I add the logs, remember I'm multiplying the arguments. So I'm doing 7 times the x plus 1, and then it still equals to 2. So we've condensed this side into a single log. Now we can rewrite this in exponential form because I see the base, 5 to the second. That's my setup right there. 5 to the second equals, and then I do 7 times x plus 1. If you want to distribute it, now you can. If you want to bring it over, it's fine. What is 5 to the second? 5 to the second is 25. So now it equals 25, and now I can solve it like normal. Okay, so I get x equals 18 over 7. Okay, and then remember, I can only log positive, so let me just check. This is a positive. If I plus 1 to it, it's still positive, so this answer is valid. Okay, let's try the next one. Okay, the log base 2 of x plus the log base 2 of x minus 2 equals 3. So this is 2 logs being added. Since they're both log base 2, I'm going to multiply their arguments. X times x minus 2 equals 3. And now that it's a single log, I can rewrite it in exponential form. So it's 2 to the third. 2 to the third equals x times x minus 2. And if you want to distribute that now, you can. I should distribute it. What is that? X squared minus 2x equals 2 for 2 to the third is 8. Okay, let me move the 8. Okay, so what do I multiply to get negative 8? 4 and 2. Which one's negative? Has to add up to negative 2, so negative 4, positive 2. So I get x equals 4, and I get x equals negative 2. Let me just make sure that these work. Okay, if I plug 4 in here, log base 2 of 4, that's good. Log base 2 of 4 minus 2, that's also positive. So x equals 4 is a good answer. How about negative 2? If I do the log base 2 of negative 2, oh, I can't log negatives. So x equals negative 2 is not a valid answer. So my only answer is x equals 4. X equals negative 2 is an extraneous answer. Okay, let's try a couple more. Okay, I have log base 4 of x minus log base 4 of 5 equals 1. Okay, let's rewrite it. Since I'm subtracting the logs, I am dividing their arguments. Okay, now that it's a single log, I can rewrite it in exponential form, so it's going to be 4 to the 1. Okay, so x over 5 equals, what's 4 to the 1? 4. Okay, how do we solve this? Yeah, let's times 5 over. Okay, so I got x equals 4 times 5, 20. Okay, let me just check. Log base 4 of 20, that's positive, and that has a 5. So x equals 20 is a good answer. Okay, one more. What are these? They're both log base 3s. If I do 2x plus 21, log base 3 of 2x plus 21 minus log base 3 of 5, I'm going to get a fraction equals 2. Okay, exponential form. 3 to the second equals 2x plus 21 over 5. So 2x plus 21 over 5 equals 9. What should we do? Let's times the 5. I don't like that fraction. Okay, if I times 5, these cancel. Okay, now we solve like normal. So 2x equals 24. Divide by 2, I get x is 12. Okay, I need to check that it's going to make my arguments positive. So 2 times 12, that's positive, plus 21, that's positive. So it's going to keep our positive arguments. So answer is x equals 12. Okay, you're going to go ahead and try the practice problems. Okay, unpause when you're ready. The answers are at the bottom. Okay, for number 1, x equals 12. For number 2, x equals 22 over 3. Okay, number 3, x equals 300. For number 4, x equals 3. Okay, for number 5, I did the log properties, but then they both had ln's. So it turns out that 5 times x plus 3 equals 35, and I got x equals 4. For 6, 4x times x is 4x squared. So I got x equals positive and negative 3. 3 was okay. Negative 3 made this log have a negative argument, so it was not okay. Okay, and then for the last one, I found that x equaled negative 5 and 2, but when I plugged in negative 5, it made me have to log a negative, which I'm not allowed to do. So negative 5 was the extraneous solution, and x equals 2 was the valid solution.